If you measure a particle on one side of the universe, you can instantly know something about another particle on the opposite side, as if the universe itself is whispering secrets from one end to the other, defying every rule we think we know about time, space, and causality. This strange phenomenon is called quantum entanglement, and it's so deeply counterintuitive that even the people who discovered it described it as spooky action at a distance. What if the universe is not quite as separate and disconnected as it looks? Let's step back for a moment and let words from ancient philosophy echo in our minds. In the dialogues of Plato, we find the idea that reality isn't just what our senses show us. There's a deeper world beneath, a realm of hidden patterns that bind everything together. Plato writes, "Reality is created by the mind. We can change our reality by changing our mind." The reflection here is almost uncanny. Thousands of years later, physics uncovers a world where particles are linked in ways we can't see. Change what happens to one, and in a mysterious way, you alter the state of another, no matter how far apart they are. Is this the hidden pattern Plato imagined, now revealed in nature's laboratory? To illustrate entanglement, imagine two coins, one in Paris and one in Tokyo. They've been specially prepared so that whenever you flip them, whatever one lands on, the other shows the opposite, even if you flip them at the exact same moment, light years apart. The fact itself strains credibility, yet this is exactly what happens in the quantum world, not with coins, but with subatomic particles. Why is this so difficult to accept? Partly because it seems to clash with everything we know about how information moves. In everyday life, information has a speed limit. No signal can travel faster than light. Yet, entanglement means two parts of a system can coordinate without any apparent communication, instantly defying this cosmic speed barrier. Albert Einstein famously hated this idea. He called it spooky action at a distance because it threatened the neat boundaries of cause and effect. He wrote, "I like to think the moon is there, even if I am not looking at it." His discomfort speaks to a core intuition we all share. Reality should persist independently of our actions, observers, or choices. But quantum entanglement suggests reality is not so clear-cut. Instead, it hints that what we call reality may exist only in some tangled network of relationships, webs that stretch across space and time, so that distant events are joined by a logic less like billiard balls colliding and more like stanzas answering each other across a poem. Let's use an image from poetry, from William Blake. To see a world in a grain of sand and a heaven in a wild flower, hold infinity in the palm of your hand and eternity in an hour. Quantum entanglement is the physical echo of this poetic insight. In the fabric of the universe, the tiniest speck can be tied, invisibly, to the fate of something unimaginably distant. Blake's vision is no longer just poetry. It's a metaphor for the mysterious connectedness in the quantum world. But how does quantum entanglement actually work? In the lab, physicists can create pairs of photons, particles of light, that are entangled. If you measure the polarization of one photon, you instantly know the polarization of the other, even before you measure it, and even if it's on the other side of the planet. You can't use this to send signals faster than light, but the correlations are real, confirmed, and measurable. They defy any explanation based only on classical physics or local secrets these photons might be hiding. These tests have gotten remarkably sophisticated. In a modern Bell test experiment, there's no way for one photon to know in advance how its partner will be observed, and no way for signals to travel fast enough to coordinate their answers. Still, the results align, as if the photons remain linked by something outside ordinary space, or outside our ordinary ideas of space. Why is this so unsettling? Because it's not just a technological curiosity. It raises philosophical questions about the nature of reality itself. Is the fabric of the world built from separate pieces, each with their own destiny, or from entangled threads so deeply interwoven that you can't pull one without tugging the other? Let's find insight in ancient scripture. In the Bhagavad Gita, the universe is described as a single tree, with roots above and branches below, unifying all things. He who sees that all actions are done in Prakriti alone, and thus that the self is not the doer, truly sees. What if, at the deepest level, reality is not about distinct individuals and things, but processes and relationships, so that what happens to one is always, in a sense, reflected elsewhere? There is a deep paradox at the heart of entanglement. On one hand, it's been proven again and again in experiments the phenomenon is real. But on the other hand, it defies common sense. You can't use it to send messages or break causality, but you also can't escape its implications for how the universe is built. Several interpretations of quantum mechanics wrestle with this. In one, called the many worlds interpretation, all possible outcomes of quantum measurements are realized in parallel universes, so there's no need for mysterious influences. In another, called hidden variables, the universe contains unseen rules or signals, but every attempt to find them has failed. In both, the strangeness remains. Let's reflect with words from the philosopher Schopenhauer. The world is my idea. In quantum physics, measurement collapses possibilities into a single actuality. Observation, in some sense, completes the picture. What you see depends fundamentally on how you look. Change the question, and the universe gives a different answer. Entanglement takes this further. There is no answer about the parts alone. Only together do they form a reality. The two entangled particles are not merely connected. They make up a single quantum object, regardless of the distance between them. Some physicists argue that entanglement is not just a weird trick of particles, but the very glue that stitches the universe together. There is a radical idea emerging. Maybe space-time itself, what we think of as location, distance, and separation, arises from networks of entanglement at the quantum level. There's no space without the links. Here we might turn to the poet Donne. No man is an island entire of itself. Every man is a piece of the continent, a part of the main. Replace man with particle, and you have a poetic lens on the quantum landscape. In a very literal sense, nothing in the quantum world stands alone. This isn't just metaphysics. It's being harnessed in technology. Quantum computers rely on entanglement to perform calculations that would take ordinary computers longer than the age of the universe. Quantum encryption uses entangled particles to build codes that can never be broken. If anyone tries to intercept the message, the act of observation itself reveals them. But at its core, quantum entanglement challenges our most basic assumption, that things are themselves, alone, with properties independent of everything else. Reality resists this lonely story. The deeper we look, the more we see that things are defined by their relationships, not by some invisible, private existence. The physicist Niels Bohr once said, "When it comes to atoms, language can be used only as poetry." Nature, at its most fundamental, resists easy description, calling us to stretch our definitions of knowledge and reality. When you think of the universe now, imagine not just empty space and scattered particles, but an invisible lattice, an intricate web, where distance means less than connection. Think of reality less as a collection of things, and more as a symphony of interactions. Maybe it has always been this way, hidden in plain sight, captured in the verses and philosophies passed down through ages. Quantum entanglement does not end the questions. Instead, it opens new ones. What is fundamental, things or relationships? Where does information really live? And if the universe is more of a connected whole than we ever imagined, how should that change the way we think about ourselves, each other, and the world we share? The lesson, perhaps, is humility. The recognition that reality is stranger, deeper, and more intertwined than our senses, or even our wildest imaginations can picture. And that every answer, for now, is the beginning of another question, rippling across the quantum fabric of the cosmos.